In previous videos, I showed the bonding and the structure of ionic compounds. Once you understand those things, you can understand the properties of ionic compounds, why they have those properties, and look at three properties. The first one is ionic compounds tend to be brittle. Brittle means that when you put a force on it, it snaps. It's the opposite of metals, which are malleable. When you put a force on a metal, it bends, whereas ionic compounds tend to snap. The reason for it, if we go to our structure of an ionic compound, at the moment we've got this attraction because of the alternating pattern of cations and anions. Let's imagine if we put a force on it and we got this row to all shift along very slightly. In that case, once it all shifted along, we'd have this situation where we've got negative, positive, negative like that. That's if the top row has just moved along by one. And suddenly, between these two rows, we've no longer got attraction, but we've got repulsion because we've got like charges next to each other. And therefore, at that point, between those layers, it would spring apart, so it'd come apart very easily. And that's why, when we apply force, they snap easily, they're brittle. Okay, the next property is ionic compounds have high melting points. Very difficult to demonstrate an ionic compound melting, because for most ionic compounds, a Bunsen burner won't go hot enough to get it to melt, like sodium chloride. They've got very high melting points. And the reason is because to get it to melt, remember from this video, we've got to break the lattice. We've got to break the electrostatic attraction between the cations and the anions. And that is a very strong force. So it requires a lot of energy to overcome. So I've got to heat it a lot to get them to melt. So I'm going to just write, because it's got strong electrostatic attraction. Third one is whether these compounds conduct electricity. Remember, the two things that something needs to have to conduct electricity is it needs to have a charged particle that is free to move. Let's look at this giant ionic lattice. It has got charged particles. It's got these cations and anions, but they are not free to move. So therefore, ionic compounds do not conduct electricity when they're solid. If I had a big crystal of sodium chloride, I wouldn't be able to hook it up to an electrical circuit and get it to conduct electricity. So, as solids, no. What about if we melt it? If we melt it, then those ions are now free to move around. So it would be able to conduct electricity. The other word for a liquid ionic compound is molten. Think like lava. That is a liquid ionic compound. It's ionic rock which has been melted. So that would conduct electricity. It's not very useful though, because you have to have it extremely hot for it to be a liquid. The other thing that you can do very easily to get the ions to move though is dissolve it in water. You could do that in the lab. You don't need to heat it at all. Just put the ionic compound into water and then the ions are free to move around because they've been separated. So in solution, when it's dissolved, ionic compounds are able to conduct electricity, but the reason is because the ions are free to move. This is different to in a metal. In a metal, the reason a metal conducts electricity is because the delocalized electrons can move around. The reason why in salt water or any kind of ionic compound dissolved in water it can conduct electricity is because the ions themselves move around and carry the current.